Welcome to episode 75 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data and AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
The godfather of deep learning. That's how many describe Geoffrey Hinton, a pioneer whose work laid the foundation for much of today's AI breakthroughs.
Geoffrey Hinton's story is like a roadmap of how neural networks went from an academic curiosity to powering real-world AI applications we use every day.
Let's start with the basics. Geoffrey Hinton is a cognitive psychologist and computer scientist who helped develop the concept of neural networks, particularly their deep learning forms. Neural networks are computing systems inspired by the structure of the human brain, but unlike simple programs, they can learn patterns from data.
That's right. And in the business world, deep learning means huge leaps in automation and prediction. Think of how companies like Tesla use neural networks to improve their self-driving cars by analyzing massive amounts of sensor data.
Exactly, Amy. But it's important to understand the backdrop. For decades, neural networks faced skepticism. Early efforts in the 1950s and 60s showed promise, but lacked the necessary data and computational power. Hinton's insights, especially in the 1980s and beyond, helped revive interest by showing new training techniques like backpropagation, which made deep networks more practical.
Backpropagation is that algorithm that basically tells a network how wrong it was and by how much, right?
Yes, in simple terms. Think of it like learning to throw darts. If your first throw misses, you adjust slightly based on where the dart ended up. Backpropagation updates the system's internal parameters to reduce error step by step.
So, thanks to Hinton's work, we moved from shallow networks with just one or two layers to multiple layers. That's the deep in deep learning. And this led to better feature extraction from raw data, which businesses could actually use.
Precisely. Before this, we had to manually design features, like telling a program exactly what shapes or edges to look for in an image. Deep networks automate that process, uncovering complex patterns themselves. Hinton's 2006 paper on deep belief networks really pushed this idea forward.
And the timing was perfect, just as data started exploding everywhere, in healthcare with patient records, in retail with customer transactions, in finance with stock market data. Companies suddenly had the tools to make sense of it all.
It's fascinating. Hinton's influence isn't just theoretical. He's been directly involved with companies. For example, he joined Google to help accelerate AI development there. His work underpins technologies like Google Photos, voice recognition, and more.
From what I've seen working with clients in finance, the breakthroughs in neural networks mean better fraud detection systems. Instead of relying on fixed rules, these systems learn patterns of fraudulent behavior, continuously improving as they see more data.
That's a perfect example. What's also noteworthy is Hinton's readiness to challenge conventions. For instance, when deep learning first gained traction, many were skeptical it would ever beat traditional machine learning methods like SVMs or decision trees. But he predicted the shift well before it became mainstream.
And even now in industry, some companies hesitate to jump fully into deep learning because of complexity or lack of interpretability, but those who do are seeing huge rewards, like better customer personalization in retail through recommendation engines, all possible thanks to his foundational work.
Let's also step back and consider the human side. Hinton's career began as cognitive psychology, trying to understand how humans learn and recognize patterns, which influenced his AI research deeply.
That's an interesting angle. It reminds me of how in healthcare AI, neural networks help interpret medical images like MRIs or X-rays by mimicking, in a way, how human radiologists identify anomalies, but at scale and speed.
Right. And the beautiful part is this blend of neuroscience inspiration and computer science innovation. Hinton's vision was to build machines that learn from data rather than rely only on explicit programming.
Another story I love is how, despite early setbacks, Hinton and his colleagues didn't give up during the AI winters, periods when funding and interest dried up. Their perseverance is a great lesson for companies adapting to AI. Transformation isn't always smooth or immediate.
That's a critical point. AI's progress has been cyclical, but foundational work like Hinton's ensures each wave stands on stronger ground. His perseverance helped unlock deep learning's potential at just the right moment.
For sure. And today, many AI products we take for granted trace back to his legacy, from virtual assistants understanding speech to smart cameras recognizing faces.
Before we wrap up, let's clearly define neural networks and deep learning for our listeners. Neural networks are layers of interconnected nodes or neurons that process data by passing signals forward.
And in practice, this means businesses can feed raw data like images, audio, or text into deep learning models to automatically detect patterns, predict outcomes, or generate new content. This has transformed industries from automotive to finance.
So what do you think is the key takeaway here, Amy?
For me, Geoffrey Hinton is more than just a scientist. He's a symbol of combining theory with perseverance. His work empowered industries to unlock the value hidden in complex data through deep learning, turning AI from idea into real-world force.
I agree. Understanding Hinton's journey helps us appreciate how foundational research, combined with practical algorithmic breakthroughs like backpropagation, paved the way for the AI systems shaping our world today.
And for those listening who want to bring AI into their own businesses, knowing this history helps set realistic expectations. Progress takes time and innovation, but it's absolutely within reach.
Next time, we'll explore another influential figure, Andrew New, who built on Hinton's work and took AI education and industry applications to new heights.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your comments or questions. Send them our way, and they might be featured in future episodes. Until tomorrow, stay curious, stay data-driven.